A useful technique which has been deployed by the commercial operators is MIMO, multiple input, multiple output antennas. It is a way of increasing the capacity in the radio channel. The starting point for any discussion on MIMO is to start with CISO, and CISO stands for single input, single output. So the yellow box represents my radio channel. The arrow on the left-hand side is my input to the radio channel, and that's going to be provided by a radio transmitter and a transmitting antenna. I can take an output from the radio channel by having a receiving antenna and a radio receiver. That's the basis of any communication system. Next stage on from that is CMO. So I have a single input to the radio channel, but multiple outputs. We've been using CMO for quite a long time, even in GSM-R, although we didn't perhaps call it CMO. We probably tended to call it receiver diversity. We'd have two receiving antennas on the mast. Both our antennas will pick up a signal. We can add those two signals together, and that gives us a bigger resultant signal. So we get this diversity gain out of the system, and that compensates for the weak uplink. One stage on from that is going to be MISO. MISO is a multiple input to the radio channel with a single output. It's sometimes called transmit diversity. It was a technique that was introduced into the 3GPP standards when the UMTS specifications came about, but I'm not aware of any mobile operators using transmit diversity. It would only be workable in a code division multiple access network. Otherwise, we'd have lots of multipath propagation issues. But what we're leading to, of course, is MIMO. So we have multiple inputs to the radio channel and multiple outputs. It's going to be more complicated. We're going to have two transmitters, two transmitting antennas. The antennas need to be spaced apart, so they need to be decorrelated to give us the best effect. And of course, on the receiving end, I would need two receiving antennas spaced apart and two radio receivers. But if I can achieve that, I can actually double the throughput in that radio channel compared to a single input, single output. So I can double the capacity, in theory, by using a MIMO configuration. I can take that a stage further. Why not have 4 transmitters and 4 transmitting antennas? And on the right-hand side, 4 radio receivers and 4 receiving antennas. I can now transmit 4 layers of information, 4 streams of information. I can quadruple my bit rate in the radio channel compared to CISO, or I can double the bit rate compared to 2x2 MIMO. So this is called 4x4 MIMO. And this technology was trialed, I believe, at the 5G Rail project in southern Germany. And it is commonly used by the commercial mobile operators as a way of putting more capacity into the actual radio channel. So I think we are going to be seeing definitely the use of MIMO in FRMCS. The problem with the receiver is not going to be the problem that we have in a commercial mobile network. Your mobile phone, my mobile phone is a small handheld device. Putting 4 antennas spaced apart as widely as possible is difficult in a mobile device. And having 4 receivers and the processing power to handle all the information is going to be quite battery unfriendly. But of course, when you're talking about kit located on a train, the so-called cab radio, space isn't really that much of a limitation compared to a handheld mobile device. So MIMO configurations are a way of maybe compensating for that lack of capacity if we're going to be using a 3 megahertz radio channel. Eventually, of course, we will refarm our GSM-R spectrum, and we can then expand our FRMCS from a 3 megahertz channel to a 5 megahertz channel. And of course, that will give us more capacity anyway.